A second way to factor is by looking at the difference of perfect squares. Now, the name of this describes what it has to be. So it has to have the difference, which means subtraction. That's where we're going to get our opposite signs. And then I have to have a perfect square. So remember our perfect squares, we looked at those: 36, 81, 64. Remember, perfect square meaning there's one number that when I multiply it by itself, I could get that value. Okay? So if I don't have subtraction and perfect squares, then I cannot use this form. Okay? So let's look at an example here. Let's say that we have 4x squared minus 25. So the first thing that I notice here, 4 is a perfect square. X squared is a perfect square. 25 is a perfect square. And I'm subtracting. So all of the things that I need, the difference and the perfect squares, it's all or nothing. They're either all perfect or I can't use it. I either have subtraction or I don't. Okay, so now that it indeed is the difference of perfect squares, I'm going to take the square root. So the square root of 4 is 2. The square root of x squared is x. The square root of 25 is 5. And I'm going to give 1 a plus and 1 a minus. That's what I mean by I'm going to make opposite signs. So I square root it all. 1 gets a plus, 1 gets a minus. It doesn't matter the order in which I do those. Okay, so what if we had 49 minus 36x squared? Okay, so again, I'm going to check to make sure that I actually have the difference of perfect squares. So I've got a perfect square of 49. I've got a subtraction, perfect square of 36, perfect square x squared. Great, it works. So now I'm going to take my square roots. Square root of 49 is 7. Square root of 36 is 6. Square root of x squared is x. 1 gets plus, and 1 gets a minus. Right? So this one's pretty straightforward. Now notice up here I put we're always going to look for a GCF. So let's see what that might look like. Let's say that we had 2x squared minus 72. So when I first look at this, I'm like, well, it's subtraction, but they're not all perfect squares. So, oh gosh, I can't do it. No, that's not what it means. Let's look at this one actually. 2 and 72. Think about the last type of factoring we did. We factored by the GCF. So if I look at 2 and 72, those can both be factored by 2. So if I divide out a 2 there, take the GCF of 2 out, then now I'm going to look at this x squared minus 36 and I say, oh, that is difference of perfect squares. 1 is a perfect square. X squared is a perfect square. 36 is a perfect square, and I'm subtracting. So now I'm going to take the square root of 1, which is 1. The square root of x squared, which is x. The square root of 36, which is 6. 1 gets a plus, 1 gets a minus. Oh, and don't forget that GCF from the beginning. All right. Oh, I think I'm off a number here. Oh, well, it's okay. So let's look at the next problem here. Let's say we have 27 minus 3x squared. Right? So upon first look, I'm thinking to myself, well, this just isn't perfect squares because, oh, wait a second. What about this GCF that we have here? 27 and 3, I can divide out by a 3. So let's divide out by a 3 and then see if we have anything. So now that we take that 3 out, I look again and I say, okay, wait a second. Now it is. because I can take the square root of 9, which gives me 3. The square root of x squared gives me x. One gets a plus, one gets a minus. Oh, and don't forget that GCF in the beginning. Okay, so when we have difference of perfect squares, first make sure that we actually have the difference of perfect squares, whether we need to take a GCF out or not. Then I'm going to take the square root of everything and I'm going to alternate the signs.